I'm Irmak, and today I will be presenting you our ongoing research project, Automata. But first of all, who are we? So, I'm from Hisar School. I'm currently a high schooler, a junior, and in our school, we have our own fabrication laboratory, the only K-12 fabrication laboratory in Turkey, which we named it as Idea Lab. Also, we've become a Fab Academy this year, and I'm hoping to take on the Fab Academy course next year. So in Idea Lab, we develop R&D projects, mostly actually regarding human-computer interaction, and we are always using like augmented reality or focusing on like machine learning, artificial intelligence, and all of them. So our project Automata, what are Automata? Automata are six kits that we designed it ourselves, manufactured ourselves, which has the main goal of introducing to kids how they can understand easily mechanical systems work. We've worked with so many STEM projects that we saw that many kids had trouble understanding mechanical systems, especially when it comes to applying them. So we designed these kits in order to help kids understand the mechanical system themselves better, but not only understanding them, building the mechanical systems on their own so that they could actually know how to build them and arrange them as they want, since it is a hands-on kit, and have the real life experience of building mechanical systems. And not only we were satisfied with them building a kit, we also integrated it with augmented reality (AR). Our main focus with AR was that in order to kids have the learning experience better and to create a bridge with technology. Like for example, the kids build the kits themselves. Like I have actually a kit here next to me. I have many of them. I'll show them. Like they built it and now they can see how the mechanical system works. But then what? Then they can see the integration with AR and actually understand how this motion is transmitted in real life, or they can have a 3D visual of it, they can look around it, and it is both like interesting for them, like, oh, a new technology, and it also helps them understand what the main purpose of that mechanical system is better. Now, firstly, I want to show the kits designs here. All six kits we have their own fusion files and their own assembly videos through which we also made from Fusion, and we are currently working on um, the sending out the kit to all 81 provinces in Turkey, because we believe that this kit could be an essential for a part of education where mechanical systems were taught. We're currently working with a foundation, which is, as you can see here, Okul Destek Derneği, which is School Support Foundation. They are working with many students all around Turkey, mostly online, and especially in parts where 2 years ago there was an earthquake in our country, Maraş, in our province, Maraş, and many students were affected. They are still having troubles of reaching for education, and we are especially helping them out, and we're preparing to sending our kids to them and helping them have access to all of our kids and give out education for them. So let me pick it and open it up. For example, this is our first kit. I'm opening it. Open. Meanwhile, that loads. I'm just gonna open an assembly video as well to show it. So here is the fusion designs of it. We designed each kit to make them represent a mechanical system. For example, this represents the cam system, and you can see that how there's a follower and how the cam turns around, and then these designs were we probably redrew this design like many, many times in order to have them finalized in looking in an aesthetic way and um, playing on the tolerances very much in order to have the satisfied motion. And here's an example assembly video of the kit. Each of these videos are 24 seconds and they, oh, okay. And like, if we have time later on, which we probably will, I will show all of these videos as well and all the designs as well, so you can take a look at them. And now I just want to talk a little about each kit themselves and what do they represent. So I opened the first kit, designs and videos, which is the cam system. Cam system is mostly used in like uh, inside of engines, or they can appear in our daily lives. And the second figure here is the our second kit. It is can be the Geneva stop. So Geneva stop is mostly used inside clocks or like where more intermittent motion is used. And our third kit is the crank system, which is also used in engines or big machines at fabrications. And our for the rest of our kits represents different gears. For example, the fourth one representing bevel gears, which also here represents how the rotational, horizontally rotational motion gets converted to vertical rotational motion. And the fifth kit has different shaped gears, which is called as weird gears as well. They have like an oval shape, which results in the torque of the transmitted motion currently changing even when you actually turn the system at a constant speed. And the last kit is how horizontally how horizontal motion is converted to. And the thing about the sixth kit is when you try to rotate it the otherwise, as I can show from here, normally you can see the follow from the picture how it is turning. And normally when you try to turn it backwards, it doesn't work. So this type of gears are mostly used in safety systems, which helps them to have a stop motion. All of these kits were designed from, as I said, and opened before Fusion 360, and we produced the kits ourselves from the 3D printers we have in our Idea Lab. And all of these kits we printed out from scratch. Like they are, there's an outline example. Here is the outline, and the pieces are inside connected with a thin rod. And students themselves take it out and watch the videos. As we used to have manuals, look from the manuals and connect them and have the end result of these kits. And these kits are on the same base. Like if you've noticed, the base part of it all in the same. So we wanted to increase sustainability and help produce our kits more faster, more efficiently. And now since they're all in the same base, like they don't have to, in the end of our workshop, they don't have to go all carrying around six kit, but instead have just one base and arrange any of the systems how they want accordingly. And hmm, now I want to show you how our kits have evolved per se. For example, here in the middle, you can see screws and you can see many tiny pieces connecting together. So as I said before, while showing the design, we played so much with um the tolerances, and we avoided using screws because from our first workshops we received many feedbacks that it was of course hard for kids to screw them or use them, or they got confused with how many small little pieces they had. So we tried to minimize the number of pieces, and we tried to help them get connected on the mechanical system instead, and we tried to use um as few pieces as possible. And the first photo is how the kits actually get printed out. And here you can see each each kit has a base themselves, but now they don't even have the base. And some systems have changed, so it is quite smaller actually. And how it is smaller also helps us to make them all feel in a smaller package. So when we send it out to kids, when we give out our education to them, it's easier for it. And in the last photo, you can see that on top of the gears, there are ballerinas. So our first approach of making these kits customizable, we thought of like, oh, like if we put a ship on top of it or we drew ballerinas on top of it, it would be interesting. But then we realized that it was hard for us to like print it all out or give it to the kids, and they had to stick it on top, which created confusion for them. And then we transferred to origami. We made videos on how they would actually do the, for example, the ship origami, and then they did it themselves. But finally, we decided to settle on AR because we believe that was the most innovative way. Now, for the AR integrations, like when you just take a look at it, you can see that all of them includes marine animals, because we also wanted to raise the awareness on how life below water, how marine animals are in the endangered, and the main cause of it is us humans. So I can show you how these ARs work. I have the photos ready, the kits ready, and we did the ARs from an app called Halo AR, and I will open it up and then show the ARs to you. So let me start, for example, from the first kit, which represents the cam automaton. So here in the interface, you can click to scan, and when you search for it, you have all the automata kits separately. And then I select which system it is, which is CAM A. And then now it is searching for the picture I set for it, which is the original picture of the kits. Let me show it like this. And now I am trying to scan it. And when I scan it, sorry. Oh, okay. So when I scan it, there's a manta ray currently on top of this. And as I move the cam system itself, the manta ray also moves according to the transmitted motion of the system. And for example, let me show the crank system. So these pictures are well normally printed out, so when light reflects on it, it's hard for the AR to actually scan it, but they actually don't have any problem working. So again, I'm selecting the dedicated system and then scanning it, and now it has a shark on top of it. Oops, sorry. It has a shark on top. So each of these ARs are each of the ARs of the kids like are quite fun to play around with. And I especially chose this app because you can create your own ARs and publish them also. So not only kids get to enhance the kits with AR, look around on how the animal moves according to the transmitted motion, but also they can enhance they can enhance these kits with their own creativity and add their own ARs. We also at the end of our workshop teach how kids can do the ARs themselves as well, and then they can actually put what they imagine to be what the motion or what animal or what anything they wanted to on top of it, and then like it's like their imagination coming to real life, coming to 3D. So what we've done with our workshop, with this project, with our workshop, last year I also participated in Fab Educators, but we sent out a video. So the picture um on the in the middle on top is from the last year's video, and we gave out uh, probably now 16 workshops. In our school, we organize a coding summit each year, and I've now participated third time this year. And in each, we've given out 4 workshops for this Automata project. And also, we've participated in another school, ACS, which was in Athens, Greece, conference and gave out this workshop 4 times as well. The key thing from our workshops was, of course, the data we received, the feedback we received. Since the kits weren't finalized in many of the workshops, since the kit was evolving, the data we received was hard to connect each time. But from our final workshop, here are some example questions about the systems, and on top you can see the accuracy and the data we were able to receive back, which was actually quite impressive because it was the first time we tested the final kits on kids, and then I tried to make the questions actually hard and actually used phrases which were terms actually used in mechanical systems, and the kits were like, okay, designed for K-12 students, but like if I when I were a fifth grader, I don't think I would be able to understand like how torque changes, but from the accuracy we received, it was actually quite impressive that the kids were actually able to grasp all the mechanical systems themselves. Thank you for listening to me, but now I will show you the videos of the kits and how the designs of them, and later on, of course, if you have any questions.
You have lots of time for any questions from the audience. Personally, I loved your project
Thank
and
you.
your models are awesome.
Thank
I have a
you.
question. Are there models available for other folks to print?
We are actually currently working on that. Like we have all
Mhm.
the links here, so and the downloading option is on. So w- we are planning to make a website which we're currently working on, and when the website is finalized, all the project will be open source, which is one of our main goals. And when we make the project open source, like anyone with a 3D printer at hand will be able to print out the kits, and since we have the assembly videos as well, they would be able to assemble the kits themselves. So yeah.
Okay, cool. Looking forward to that.
And also, our Idea Lab has an Udemy account in which we give out lessons. For example, there is a similar project we did, the Lemon Kits, which is also a hands-on kit helping to teach kids like the basics of electronics, mechanics, programming, etc. We have videos for it, and the kids can look up, or anyone can look up from Udemy, the educational videos of it, and then do the kits accordingly, and we are taking the same videos for this project Automata as well. So not only that we will have an open source website, but also we will have our own course at Udemy, which is dedicated to teaching these kids. So here are the fusion designs.
If I may, sorry. The main goal of your project is to use these designs specifically in class, right? Uh, don't take this as a criticism, but are you planning to go to the next level to find ways for your students to customize or to change to incorporate these designs in projects that make use of this mechanical knowledge? Because it's perfect to bridge, as your presentation made it very clear, to bridge the gap between theoretical learning and practical learning. Because when we are learning about mechanics, we can see all the videos and PowerPoints of everything, but if you don't touch, it's complicated. It's complex to understand deeply what you are talking about. So, but the thing is, this kind of mechanisms are also amazing to create stuff for arts. Instead of, I don't think I'm being clear. Uh, Instead of just being the mechanical device, uses for the mechanical device. Maybe it's, do you do you think it's
Um,
foreseeable?
as I understood, you're asking for like okay, they did the kits, but how do they actually understand the system or how they can actually use the system?
Actually, it was not a clear question. My apologies. No, okay. So your students print and assemble the mechanical devices, right?
No, we print the kits and hand it out to them.
Okay,
The thing
so
is,
same thing. Okay, same thing. But can they incorporate the mechanical device? Sorry, my dog is clingy. Sorry. Can they incorporate the mechanical device in other projects? For example, they could build, for example, like a robot using your mechanical designs.
so uh we we're actually planning on to make a collusion with my friend, which also has a project. I'm not sure if this will answer your question, but he also presented here in the previous session. He has a project called Parametrics, in which you can freely design anything freely 3D design anything you want just by giving prompts to it. So we will merge our projects when we have finalized them by we will have the kits in his application, and then they would be able to customize the designs of it. So I think then
Yeah,
the
it's
kids would also be able to make any integrate these kits with any robots you said, or for example anything they want to with. So currently, since
to be honest, I look at your mechanical designs and I'm thinking, what if I put some arms and a head? Uh, how would it move? And it's the kind of uh, non-linear ways of thinking that teachers that are more into the arts like to explore. And your devices look to me like a very great way to do that.
yeah, that's why at first, like I think here in the photo you can see
Yeah.
we had it decorated as a sea because we put like sea origami, ship origamis on top. But we thought that using AI was more of a engaging way, and like it was a new technological approach to this project, and we believe that by enhancing with AI, the kids like would be able to not physically see, not physically touch, sorry, what was going on, but they could customize the ARs themselves. So you said, for example, a hat, they could just search up a hats and put it on to the air on their own, and then they could see the hats on the top actually moving. So we prefer the customizability throughout the AR.
That's excellent. So I'm seeing more participants on this session. Anyone wants to join in, ask ask some questions? Maybe Paulo or Samuel. I think I scared a couple of people away.
Oh, and also here you can scan and take a look at our previously published poster paper, which was for the MUM conference at Sweden, which is a mobile and ubiquitous media, the MUM stands for. And like if you have any recommendations as you did, you can contact us from this email.
Sure.
And maybe I could just do a conclusion because I feel like,
Yeah,
especially in the big, I talked
I mean,
super fast and probably yeah, skipped many things. So again, for the final time, we designed 6 kits which helped kids understand mechanical systems themselves. These mechanical systems are like gears or crank systems or cam systems, which is seen constantly in our daily lives. And as you can see from how we're working in the Idea Lab, we are constantly doing STEM related projects, and while doing those projects, we saw that kids were not able to grasp the mechanical systems themselves. And especially we saw while uh working at FRC, the kids weren't able to understand any of the mechanical systems at the robotic competitions. So we designed kits for them. And these kids, just making them themselves or just standing there on their own is okay. They learn how to do the kits. But to finalize, we integrated the kits with AI so that it will be customized so that it will carry more of the STEM topics, especially technology. And so it would be customized and they would be able to see and put any design they want on top of the kits. And we are working on having all of these we actually have the documentations, but we're working on to make it open sourced. And yeah. Does anyone have any questions?
I think people are first, I think people were amazed, even though they are keeping quiet. Secondly, congratulations on the project. It is a very, very interesting way to make tangible something that is quite complex. I know what I'm talking about. I used to teach
This
arts
is,
and exactly that. Sorry, anyone with a question?
I didn't have a question, but I said this is a fantastic project for, I'd love to see more of it as we go forward. Because it's very hard to get kids to visualize and understand, um, gears and cam systems and such, and having pieces and like puzzle parts almost to put together is just a fantastic idea. Thank you for the presentation. It was great.